Hey everyone, so I'm Micah VanderHart. I am working with Dr. Tom Marsik on developing a low-cost active vacuum installation control system for buildings. So here's my presentation overview, and you have already seen this multiple times, so I'm going to skip it. So bottom line up front, I am trying to create a low-cost active vacuum installation control system to eventually commercialize. So kind of the bigger picture. Raise your hand if you enjoy paying your heating bills.
I love it.
Okay, now raise your hand if you would like a 90% discount on your energy, on your heating bills. Yeah, that's about what I thought. So vacuum installation panels can be up to about 10 times as effective as traditional building installation. This is because the main source of heat conduction throughout from the inside to the outside of the wall is the air inside the panels. So by creating a vacuum and sucking all that air out, you get much better insulation properties. What this means is that buildings with this active vacuum insulation technology can have much lower heating or cooling demands. They can have much lower heating energy costs, and then the associated CO2 emissions are much lower as well. So this project is working on improving the technical and economic feasibility of these systems. So my research project goals was to source a low-cost vacuum pump, a pressure sensor, and a vacuum pump isolation valve to keep it separate from the panels when it's off. And this forms kind of the backbone of the vacuum system. And then another research goal was to create a Raspberry Pi-based control system to monitor the pressure and to actuate the vacuum pump to turn on and off and keep the pressure within the panels within a specified range. And then write code to develop this control system to make sure that this all works together. It can be automatically run 24/7, and it keeps it without any human intervention. So research methods. My main research method for this project was product research online. A lot of Googling, a lot of talking with suppliers and manufacturers, and trying to find the best and the lowest cost and the most feasible components that we need for our project. And then the second research method of mine was learning to code to create the Raspberry Pi-based control system. So here's what the system actually looks like. On the left, you can have a prototype of the full system. We have the vacuum pump right here, and then we have a line of tubes, and then each tube branches off and goes to each individual panel. And this is a prototype of our full system, and it uses very expensive components. So it's not something we want to make into a product right now. And then on the right, we have the prototype control system, and this uses the Raspberry Pi, and we have a knob here that basically you turn the knob to simulate the pressure level in the panels. So basically, the panels inevitably leak over time, and so you can turn that knob to kind of simulate the leaking. And then if the pressure gets too high, the insulation ability is deteriorating. And so you turn on the pump, and I have the LED there in my control board to kind of simulate the pump turning on, and that will lower the pressure. And then the Raspberry Pi monitors the pressure throughout the whole process to make sure that nothing's going wrong. So I built that to kind of like a prototype, kind of show how the full control system would work. So I learned a lot of lessons throughout this project. First one is that we need high vacuum range components, and these are very expensive. They're primarily used in the scientific industry. And what that means is that they're low volume, not mass produced generally. They used in very niche industries. And so they're very expensive, or you're expected to use the components with a very expensive ecosystem. Another big lesson I learned was that asking vendors the right questions is very important. So an example of a very bad question is, will this sensor work with the Raspberry Pi? So first of all, there was like at least one vendor who never even heard about a Raspberry Pi before, so that's not great. And even if they did know about it, it's like they expect that you want a fully featured, like a plug and play solution with technical support, and you just want it to work. And if they've never worked with the Raspberry Pi before, they're just going to flat out tell you, no, this will not work. Do not do this. I learned that the hard way. So a much better question would be, what are the sensor's electrical requirements? That's something that they definitively know. And that's something that they can hopefully give to you. And then you can use that information to design a way to interface it with the Raspberry Pi. So it's much lower level question, much more easy for them to answer. And then another big lesson I learned was to try to find resources from people who have the same goals or who are doing the same things or similar things as you are. So it turns out that the very best source of information on pressure sensors was a group of DIY community. It was like a hobbyists who were designing and building nuclear fusion reactors in their houses. So yeah, I was kind of not expecting that, but I guess they need components to be low cost, and that kind of aligns with our goals. They're called fusers, if you want to look them up. Yeah, it's kind of crazy. So in conclusion, I developed and coded a prototype control system to turn on and off the pump. And I identified several components that could work for our needs, low cost and viable, and work for specifications that we can do. This research project will eventually transition to becoming my master's thesis in my project. So I look forward to definitely doing a lot more work later on down the line. One of the things I think this internship could have done better is that most of my work was product research, and I would have liked a bit more hands-on work, but that's just kind of the nature of the project. Like, you gotta do a lot of research and select the components before we can buy them and put them all together. So I definitely look forward to buying the components and starting to work with them in the next semester. And then one of the things I enjoyed most about the project was learning Python to code the Raspberry Pi to make that prototype control system. Yeah, that's the end of my talk. Any questions? Yes.
So it seemed like for this prototype, you need to be putting in some energy to run the pump to maintain your vacuum insulation. So my first question is, in a sort of future scenario where you actually have insulation like this in your home, do you still need to be running a pump? And if so, do you have a sense for how that energy requirement stacks up to, say, heating your home, or the heat that you would require with maybe more insulation?
So the idea is that maybe the pump runs for a few hours once a week. Okay. So when the pressure gets too high, it says, okay, you need to turn the pump on, and then a few hours later, the pressure's good, so we turn it off. We haven't done an economical feasibility study on if the power the pump uses is going to be offset by the energy savings, but we think, you know, if it's 10 times better, we think that's pretty good. We think that odds are pretty good that this will be economically feasible. Yes.
Just to follow up to that, I think a direct comparison would be hard because what you're losing is heat, and what you're paying for is electricity, and the cost of electricity and heat are not really comparable. It's like if you typically use electric heat, yeah, you can compare directly, but if you use, you know, something like, you know, forced air, you know, burning a fuel like natural gas or wood in our case, or oil, you can't compare directly. So, I mean, obviously you can compare dollars, but then it's not the same for everybody. Like when you hand out a pamphlet to sell this thing, it would be more complicated than.
Yeah, it would be. We're not at that stage yet.
Yeah.
This is like the vacuum pump we're using is like half a horsepower or so. So that's about like 300, 350 watts. If you think about running that for like a few hours a week versus running a 350 watt heater for a few hours a week, we think you're going to get much more benefit from the vacuum installation system. Yes.
What level vacuum can you need?
In terms of pressure, they perform best from about 10 millitorr to 100 millitorr. So that's kind of the range we're looking at. Yes.
What's that in PSI?
What's that in PSI? Very, very low, very small. Yeah, once you get down to like those level of pressures, like they start rating it in terms of absolute vacuum, which is like vacuum from zero, and they no longer use PSI. Yes.
How expensive are the expensive sensors you talked about?
I actually found like good sensors for about $50 to $100. The issue is that they want you to pair them with like a $500 to $700 controller. And that controller is about 2 PCBs that I think should cost no more than $100. But that's just my opinion. I'm gonna try to reverse engineer that for less than $100. And hopefully that goes well. Yeah, any other questions?